Yeah, so welcome everyone to the first edition of NLPaSE. Okay, so this is the first international workshop on natural language processing advancements for software engineering, which is co-located with the 27th Asia Pacific Software Engineering Conference. So ideally, the workshop needs to happen physically in Singapore, but due to this unprecedented situation, we met virtually here. So typically, the natural language processing, that is NLP, a very big name, has played an important role in automating the various software engineering processes. Like you have the requirements analysis, requirements solicitations, uh, identifying design artifacts, test automation, maintenance, and so on. So the need for automation in the software engineering domain was the use of various techniques for reducing the effort and cost cutting wherever possible. So the automation is not only limited to the software development, it reaches to various domains like automobile, embedded systems, and others. So especially the requirements are volatile in nature and it requires a huge amount of effort in assessing their quality. So natural language processing and its advancements have brought a lot of changes in analyzing the software artifacts and processing the information. So we have started this first edition of NPLSE. So the main aim of this workshop is to bring out the existing techniques, their limitations, and discussions which may result in future collaborations and advancements. So another important goal is to identify the areas where NLP was applied. Typically, we are also interested to have a discussions on the limitations as well as challenges and and basically where it can be applied or maybe the possible directions to bring out the researchers or the industry practitioners in a platform where we can interact, share our experiences, and then further we have the collaborations. So NLPAC consists of this year two keynote talks by Professor Michael Fedler and Professor Fabiano. So we have received a total of 5 papers for the presentation and publications from both Asian and European regions. So each paper was reviewed by 3 program committee members, and finally we have 3 of them for the presentations and for the publication. So typically the talks and papers are really very interesting, which you will hear in the course of action soon. So we welcome, so we welcome all the participants. We welcome all the participants, the authors in the workshop. So first, we will start our workshop with the keynote talk by Professor Michael. So first, I thank Michael for accepting our invitation. So Michael is an associate professor at the Department of Computer Science at the University of Eisenberg, Austria, and he is also a guest professor at BIT, that is a Berkeley Institute of Technology. So his field of expertise are actually a lot. So it is very much it is not I cannot summarize in few lines, but mostly he's working on software quality testing, requirements engineering, model-based software engineering, software engineering educations, and so on. So he co-authored more than 150 publications and received 10 Best Paper Awards. He has more than 15 years of industrial experience as a executive consultant, project manager, and software engineer. He is also a co-founder of the startup QE Labs Business Services. And then he is an internationally recognized member in the software engineering research community. And he also served as the editorial board member of several journals, organizer of conferences, editors, and so on. So I welcome Professor Michael Fedler for his talk. So the title of the talk is Natural Language Processing in System Verification, Current Approaches and Future Directions. So I request Professor Michael to please take over the charge and then give a lot of insight about this talk to the participants and the audience.
So, thank you very much. Can you hear me well? Can you see my slides?
Yes. We can.
Okay.
Yeah.
Great. So welcome everyone to my keynotes. entitled Natural Language Processing in System Verification, Current Approaches and Future Directions. Many thanks again to Saurabh for the kind introduction, which really honored me a lot. It's also great to be here and to have the chance today to share recent work and ideas with you. As Saurabh already said, I'm a professor of software engineering at the University of Innsbruck in Austria, and I also hold a guest professorship at the Blaking Institute of Technologies, which is especially recognized well in empirical software engineering. I have published a lot, have also a lot of experience, and my main areas of research these days are linked to software quality, AI and software engineering, requirements engineering, and in general, the application of empirical methods in software engineering. So given that background, I want to start my talk, and as my focus is on software verification and testing in this talk, I first want to highlight, as many of you may know, that automation is very common in code-based testing, or even in testing based on formal languages, may it be model-based testing, right? On the right, you see an example. If you have source code, for instance, unit tests, then it's there are many tools around. This is the example of EvoSuite, a well-recognized test automation tool. You can press a button and you get automated test cases, right? So that's not something that is very, very special these days. That's already state of the art, and is becoming state of the practice even better. And also other problems in testing that rely on code or formal specifications have been well automated, may it be the measurement of coverage or also the dependency detection of test cases, a problem that I will also tackle in my talk, where we try to identify relationships between test cases. Test cases that are very likely to have a same output, may it be pass or fail. That's test case dependency detection. So given that background, many of you may, if they are from practice, may have recognized that automation is really not that advanced for obvious reasons when it comes to system level testing, and especially then to requirements that are formulated in natural languages or in structured natural languages. That's a much harder field to come up with automation, because in the past it was also a reason that it was not possible to somehow get the structure behind natural language. But these days, with all these advances in natural language processing, there is a great potential, and I think this workshop is also a very good venue to bring this forward, to actually exploit the potential of natural language processing in the context of system testing, or we can also call it in this sense system verification, because you always rely then on a specification given, in this case in natural language, to actually test it and to derive test cases. Here you can see a very basic example. It's just a classical requirement that you may find. If the user enters valid username and password, and the system should let the user log in, right? So a requirement that you have more or less in every system that has some user interaction these days. And different types of natural language processing allow you to extract some structure and to use that structure then for testing purposes. I don't want to go into details here. You can just see different approaches, like the part of speech approach, where you get the different morphemes. You can then even get relationships between them by basic dependency parsing. You may even do semantic row labeling, identifying actors, predicates, and actions, or you can even go more advanced and try to extract an information model to identify entities and relationships, so even have a meta model behind it. So there are different ways to extract concepts from a natural language text. Yeah, and the goal is then to identify test cases, and just to give those that do not have a background in testing at all, what basic test cases could look like. I mean, in this case, it can really just be that you extract what are the input fields, right? It would be name and password, and what an expected output would be. So if a user tries to enter username and password, then that he's logged in. Or that's also an important thing, not only to derive a positive test case, but also a negative one, in the sense that when you enter an invalid password or username, then you are not logged in, right? So this is what natural language processing can support you. I mean, often it's not possible to generate entire test cases, but at least you get support for it. And what I want to do in my talk is I want to give you an overview of the current state of natural language processing in software verification and testing. And then I want to dive deep into one problem where we actually did research. Yeah, this is the identification of dependencies between test cases. And then I want to close with some outlook on future directions that I see important. Okay, so here you can see that there is a growing interest in natural language processing. Why? We did a systematic literature review on natural language processing assisted software testing. Yeah, as you can see here, this was published this year, but the actual data, it is based on stopped in 2017. So it took us some time to get it published, but I think what you can still see here is the overall trend. Yeah, namely that the number of publications increased per year. Overall, we found 67 papers that apply natural language processing in the context of testing, right? And over the year, so starting with the first publication in 2001, we see an increase of the number of publications, and I claim that the number is even increasing in the years after 2017, given the publications that I have seen, and also the publications that we even contributed ourselves. Yeah, so we can see the area is growing. There is still much to do, and especially also for this community, I think there is lots of potential to contribute. Yeah. So whenever I have now this label SLR, then this is some information that I extracted from the systematic literature review. It was published in the ISD journal, so you can easily find it online. We also have a preprint freely available online, so everyone should get access to it, also to the underlying data. Okay, then. Another next important thing that we investigated in this systematic literature review was which are the actual approaches that are applied for the testing purposes here. And here we see that most approaches rely on part of speech analysis. Yeah, what we have seen here before, more a basic approach, right? A quite basic approach that works here on the morphologic level, but also stemming or named entity recognition or dependency parsing, that we have seen are quite common, and approaches that are more semantic oriented, like the semantic role labeling, or even word sense disambiguation, that even tries to take synonyms into account are more rare. But also here, the message is due to recent developments in the field, also due to this, for instance, word-to-vec approach that I will show and that we applied in our work, there is lots of potential to have more advanced approaches on the semantic level. So also, given that the field is quite, that natural language processing has been applied for 2 decades now, right? Also in times where approaches were not that advanced, it's to some extent obvious that the applied approaches in the past, are more on the basic levels. Okay, regarding the tools, the interesting thing here is that the Stanford parser has been heavily applied, and you can see a quite range. Some of these tools are not well known. Even I don't know them. And recently upcoming Python libraries, you can see, are not that still not that commonly applied, at least until 2017. This Gensim, for instance, that we also applied in our work. This is upcoming, but again, you can see here also this historical development in the application also of approaches that are not commonly used these days anymore. Yeah, then another important aspect is which types of research questions have been studied. So here we can say that many of these papers do not study research questions at all, right? They just develop an approach and then they stop, right? They just show it works even without formulating a feasibility research question, but for sure feasibility research questions are quite important. Examples are here. From use case descriptions, can we generate concrete test procedures and test cases, or how much training data is required for the proposed approach? Yeah, things like that, to show that the approach works in principle, which is also not trivial for that area. Then other questions go in the direction of assessing the precision, efficiency, and comprehensibility. Questions in that respect are, to what extent does the tool reduce the number of false positives that test input generation tools produce, or are the test cases readable and comprehensible? So the generated ones based on natural language processing. And other questions take into account the testing effort, whether it can be reduced. So this is then more, I would say, industry driven, right? Where you really want to not only for curiosity investigate whether language processing works at all and how effective it is, but you even want to measure an effort, right? And the effort can be the reduction of time or whether in that case of this research question, can we reduce the burden on programmers by utilizing information in the natural language so that they don't have to write the glue code. And finally, comparison of approaches is also very common. For instance, here, does word-to-vec allow better results compared to using the RNN model only? So here you compare actual deep learning based natural language approaches. Yeah, so that's the range of questions. But still, and then another important aspect is also how the approaches have been evaluated. So what are the actual measures to answer the research questions? So in most cases, there are just proofs of concepts, so that the approach works at all. For mostly some are some more toy examples, but then more advanced approaches are accuracy measurements, reduction of the effort, coverage measurement, even mutation analysis, then comparison to manual test cases, detection of real faults, and others. So you can see there are also more advanced measures. But overall, as I stated, the field, at least until 2017, for the years after, I have some feeling it becomes better, but no empirical evidence, as I have here in this systematic literature review. We can still see that we called it weak empirical studies are dominant. So the weak ones are those that just develop a proof of concept and investigate feasibility, but they do not go ahead measuring performance measures, effort reductions, and really compare approaches, right? So that's still these strong empirical studies that we can see here in green are rather rare. Okay, now I want to switch the context a bit, as promised. I don't want to just present what others did and summarize it and give an overview, although I think this is very interesting for this audience to get an overview. I want to address a concrete problem that we investigated in a study. And the first, so it's the context of systems engineering of train control systems. And in this context, we have to take into account on what levels are we testing, right? And when it comes to natural language processing, these are the upper layers, yeah. And in our case, I mean, we have more or less have the V model. We do not consider at all the level of the actual architecture or the source code, right? So our world are the requirements and the system test cases that are formulated in natural language or in some structured natural language, at least in tabular form, right? And we test the requirements based on tests that are derived manually from the system requirements, or we also consider the high-level system architecture and want to test the system integration. Yeah, so these two levels are not so easy to separate, and in general, these are the layers that are done by separate test departments, right? And also in our case, this is the setting, and these tests are often, especially if you are in a system context, we will see then an example, like train control systems in our case, this is also very expensive because you need also special test environments to make testing possible, right? You cannot, you do not have entire trains ready, right? When you want to test the train control system, so you need the entire test harness to make testing possible. And also due to that reason, it's important to this to the issue that executing tests is very expensive here and time consuming. You need some advancements, right? And the advancements could be the generation of test cases. That's one topic, but the topic that we are interested in is more to identify dependencies between test cases. I will come in a second why we investigate that problem. But first, let's look more into detail how the system is structured. I mean, I already mentioned these aspects to a large extent. I mean, you have modules, they are related, right? Via signals. Here we can see different systems, a door open system, brake system, high voltage system, the link to the human machine interface and so on. But I don't think these technical details are relevant here because we are anyway not that interested in the architecture per se, but more on the requirements that are linked to the modules, right? I mean, each of these modules has requirements, for instance, whether the door under which condition the door has to open, right? This is for sure linked to the brake system. I mean, if the train stops and so on. And then in addition, we have test cases, right? And the test cases are linked to the requirements because the requirements state how the system should behave. and from that you can derive test cases and also the expected behavior, right, when the test case is successful, or even robustness test cases where you try to test the robustness via unexpected situation, like that the brake blocks or whatever. Okay, and the situation is in this systems domain, in this heavyweight systems domain, heavyweight in the sense that you still have lots of requirements, documents, you have handwritten test cases. So for someone who writes modern apps, right, this is heavyweight, but still in that context, it's needed. You have the situation that you have test cases, and we can see here test cases. So this is one for the overall drive system, and here you have one for the door, one for the brake, another one for the brake, and another one for the door. And here we can see relationships between the test cases. These relationships mean, for instance, if this test case X doors fails, right, then also this gray test case brake fails. So this means if that one fails, we don't have to test that one. And that's very important in this area, as I said, because these test cases are executed manually, and the execution of such a test case may take hours, right? That's the point. So if you have a test strategy that would execute this black one first, right, and then this one second, third, fifth, and fourth, then you really lose a lot. You may lose a lot because if this test case drive fails, you still execute that one. Although if you would have executed just this X doors test case, you would not have needed to execute that one at all, right? And an optimal test strategy could then look like this. You can see this in blue. You take first all these leaves, so this more or less independent test cases, like that one, the brake is not dependent on another one, so you execute that one. If that one, then you execute that one that's also independent, right? Then you take the 3 one, and then the 4, because the 4 depends on the 3, and finally the 5, and you only execute this test case 5 if all other test cases before passed, right? And otherwise you don't need it because it's dependent, and it also fails if one of the other test cases fails. So if we did a ex post study on the data, so we are collaborating here with Bombardier Transportation in Sweden, and we figured out if we would execute the red strategy, right, so not taking dependencies into account at all, executing the worst strategy, then we would need to test this scenario 45 hours. And if we actually take these dependencies into account, so only executing dependent ones, I mean, it took several iterations into account, then we only need 5 hours. So here we have a saving of 40 hours. I mean, it's taking into account that we have 5 hours, right, then this is really a saving of 800%, right? So this is really, really amazing what you can save here. But what you need in order to make this happen is you need to know which test cases depend on each other. That's the prerequisite. And this is actually the problem that we want to investigate. First, let's look deeper how test cases look like here. Test cases look as follows. I mean, you have they have a name for sure, then they have a test configuration, the platform needed, then they, in optimal case, they are linked to requirements, and then they have an initial state, so you are ready to drive, and so on. And then you have the test steps, so you set the train speeds to 36 kilometers per hour. If you do so, then check that an IDU, no event regarding undue force stage, is shown. If this is the case, then this step passes, then you lock something, and finally you you repeat it and you always have the answer. And if this is fulfilled, then it passes, and then the manual tester may go through these steps, yeah, and tick, yes, this works, tick, this works, and another step may not work. And then we have a fail for that test case. So we have here a natural language included, right? And in optimal case, yeah, this is, we can see here, these test cases are linked to requirements. And if we have these links to requirements, which is unfortunately not the case in practice, only very partially, then the dependency detection problem would be quite easy and would not need a natural language processing at all. It would just need this graph that you can see here, right? So you would have your modules. The modules may be linked or not. So 1 and 2 are linked, 3 is independent. And then the modules are linked to requirements, and further the requirements are linked to test cases, right? And then we can define what dependency means. Functional dependency here means that so we say two test cases are functionally dependent if they are designed to test different parts of the same function. Yeah, would be here test case 1 and test case 1 and test case 3 are dependent because they test different parts of the same function, of the same module, or if they are testing the interaction between dependent functions. So if module 1 and 2 are dependent, yeah, then even test case 1 and test case 5 would be dependent, to say it easily. But test case 6 here is independent. Okay, but now we come to the research problem. So again, here we can see the entire system, right? We have here our modules, the linked requirements, and the test cases linked to the requirements. But in practice, we often have the following situation that we have the test cases without the actual links to the requirements, because they are still not linked, or the requirements were changed and new test cases were added because someone found that's an interesting test cases. So we want to identify the relationship or to say it other, that the dependencies between the test cases based just on the test cases themselves. And what do they contain? Natural language, if we don't take the links to the requirements into account, right? So we take into account, that is the problem that we want to solve. We want to identify dependencies between the test cases based on the natural language texts that we find in the test cases. And what are the important artifacts here? It's on the one hand the initial states that we take into account, and the actions that I showed you before, for instance, setting the speed to 36 kilometers per hour, as well as the reaction text, right? These texts we take into account to identify clusters of test cases. And if two test cases are in one cluster, we claim they are dependent on each other. That's what we want to address. And yes, here I just show you the research process. As I mean, you may, all of you may know, because we are doing software engineering research. So just to claim, yeah, this is often a disclaimer that I have not invented the underlying natural language processing approach or the clustering approach that we apply myself, right? Because when I talk to outsiders, not from software engineering, they often think that. So this is always the disclaimer. What we do, we address software engineering problem, yeah, namely we here develop a method to find test case dependencies between natural language test cases, right? The domain for that we solve this problem is the domain of mobility, in that case of train control systems, right? And in order to address that problem, we take some approaches from natural language processing. Okay, so first we refine the dependency definition. So we introduce something that we call semantic dependency, right? A semantic dependency. that refines the functional dependency that we have seen before, in the sense that we say that two test cases are semantically dependent or similar if they occur in similar contexts, right? And our context is the initial state, the action, and the reaction. So we take that into account. And our claim is if test cases are semantically dependent, in the sense they appear in the same context, which we can analyze with natural language processing, then they also correlate, so then they also are functionally dependent. So we claim that semantic dependency and functional dependency correlate, which for sure we have to show, right? And this is the major contribution of our work. I mean, just applying the natural language approach itself would not be, let's say, that difficult, but then evaluating it, getting the right ground truth, that I would say is the big challenge that we addressed. Yeah. Okay, that's the actual problem that we investigate. And here you can see the approach that we actually applied. So we start with our test specifications. That's our input, right? Then we apply the doc-to-vec approach based on the data that we extracted. So the initial state, the actions, and the reactions. Yeah, we apply doc-to-vec. This gives us for the different words. Yeah, it gives us a vector space. Yeah, and or actually it gives it for us for the test cases. Yeah, each test case is represented as a vector. Yeah? And then we can, based on the similarity measure, we can do clustering, right? And we form clusters of the test cases. For that purpose, we apply HDB scan and fuzzy clustering means. And for visual representation, we do some dimensional reduction. I will show you that. And what we get, I think that's the interesting thing, we get the test case dependencies, right? That is what we get from the clustering. And we can then say if two test cases are in the same cluster, they are dependent. And we published that last year in the first international conference on artificial intelligence testing. Okay, the approach, as I said, it's based on doc-to-vec, right? So this is a semantic approach that actually, I mean, word-to-vec, you may know, doc-to-vec is an extension that also takes the paragraph context into account, right? And it actually encodes, in our case, test cases in a way that if we compute the similarity between two test cases, then the similarity is high if the test cases are semantically similar. So if they use the same words in the same context, yeah, that's the story told easy. And there are great Python-based libraries these days to actually analyze this. And if we apply doc-to-vec and then apply the two clustering approaches and apply the dimensional reduction for the visualization, then we get something, what you can see here, right? These are clouds, and each of, if two test cases, if 2 points, that's what I have to say here, or 2 dots, whatever you want to call it, if they have the same color, then they are, or the same color and shape, then they are in the same cluster, right? And we applied 2 algorithms for that purpose to identify which one works better. So HDB scan. HDB scan is a density-based approach. So there you form the clusters based on density areas. So we have our space. Yeah, we take the cosine similarity to identify the distances between our test case vectors, right? And yeah, the HDB scan tries to get the clusters based on areas that are dense, yeah, where the distances are low, and the FASE mean cluster, you need to give it some centroids to start. So it's a center-based clustering approach, and then it develops the clusters based on that. Yeah, and in order to actually evaluate the approach, we compared the performance of the test dependency detection for this HDP scan and the FASE mean clustering approach. And we did that also based on data from the same context. Yeah, it's from another project, the subway from Stockholm, and there we have different sub-level function groups. So these are the modules that I showed before, then around 4,000 requirements linked to that modules, and about 1,750 test cases linked to these requirements. Yeah, and we actually want to find out the dependencies between the test cases just based on the natural language, on their texts, right? Based on the approach that I showed you on the Doc2Vec and on the clustering. Okay, and we want to do research. So the actual idea here is to figure out how well the approach works, right? And for that, we need some ground truth. What does this mean? We need to know when are test cases really, as I said, just applying the approach Doc2Vec and the clustering on test cases. That's the easier part, right? So that can easily be done by a student. But what you also need, you want to investigate whether these test cases are then really related. And for that, you need some ground truth where we actually know whether the test cases are related or not, right? And here you can actually see our ground truth visualized. Yeah. So we took the specification, which or all this data, the requirements, the test cases, the modules, yeah, and tried to identify the relationships. Yeah. And how have we done that? So what you can see here in blue are requirements, right? And then we have test cases. These are the red dots linked to the requirements, and furthermore, also the requirements may link to each other if because of the requirements are linked to modules, yeah, and the modules may be functionally dependent on each other via the calls, right? And based on that, we get the graph. Test cases linked to requirements and requirements linked to each other. And based on that, we can then define distances. I mean, because it's then the question is, what does dependence mean, right? We solve that by introducing a distance measure. So we say the distance here is 2. We have one test case. They are linked to the same requirement, right? But we can also have the situation that we have one requirement, one test, and 3 requirements in the middle, and again a test case. So here the distance would be 4, right? And another situation could be the following, right? Also here we have distance 4, and yes, now we. I think that's technical detail. So how actually the text that we used looks like. Yeah, this is what we extracted, and this is exactly the text that we took then for our Doc2Vec approach. Sometimes we have the links to requirements, right? That helped us to partially identify that graph, but this was not sufficient at all, right? We also had to talk to people. We had to look into the architectural specification and so on. Finally, we had our ground truth path, and we applied the approach, which led to 393 clusters for HDP scan, and some points, 526 data points that were not added to clusters. And with the FASE mean clustering approach, we took this 393 basic clusters as a starting point, and applied it because we need centroids here. And here we then applied the approach, and the FASE C-mean clustering gives you then some degree of whether a specific test case vector belongs to a cluster or not. But again, here the details you see in the books, not in the book, in the paper, in the AI testing one. Okay, how did we actually do then the evaluation? The evaluation is then done as follows, right? So we take the distance as a variable. So here we say that the two test cases are really dependent on each other if they have a distance of 2, right? If in our graph with the red and the blue nodes that I showed you, yeah, if the distance is 2, then they are actually related, otherwise not, yeah. And we have this up to 10 shown here overall. The longest distance was 22, and we actually investigated that for all possible pairs of test cases, right? And we had, as I said before, 1,748. So all the number of possible pairs is quite large, 1.5 million, right? And we then took pair and figured out, are they actually dependent on each other with here a distance of 2, yeah, in the underlying graph. And what does our algorithm, so what does our clustering actually say? Are they related or not, right? And what we can see here, for sure, so you see the true positives, true negatives, false positives, and false negatives that we get. And for sure, the number of true positives increases, right? Because test cases may be dependent on a larger distance, yeah. And we can also see that the let's say the true positives are the number of true positives or also true negatives, yeah. So there is really a misbalance, may lead to the situation that you get a bias in your actual recall and precision measurements. Yeah? So we can see this here, that especially the precision values are rather low, right? For sure, which is obvious, yeah, because we have a very low number of actual true positives, so also the precision values are low here. Yes, and also for a recall, the numbers are not high. So what we actually did, this is now means some tweaking, right? So we did some so-called random undersampling. So we did more or less balance the data, right? So we took just a random sample from this set of not dependent test cases, right? And also the same amount from the dependent test cases, yeah. And this is the sampling is done several times, yeah, in order to also get out some random bias. And then we did the same analysis again, right? And then we get more reasonable scores for precision and recall. I think I don't have to talk. I think anyway, I'm running out of time. I have to talk too much about how precision and recall are defined. But what I want to show you here is that we got HDB scan performed better, right, with respect to precision recall and accuracy. So the accuracy measure here in best case was 80%. Precision then is astonishingly high. So we get all the we have really a very high precision of what dependencies we find. A reasonable amount of the dependencies we actually get back. And if we take into account, right, that we mainly apply this approach also to reduce the effort. Then precision is a very important measure, right? Because it really gives us the a high degree of dependencies, right? Not all of them, but a very high degree of them. And also the accuracy is reasonable. So if we look again back to the systematic literature review, then we see, so these are the accuracy values reported in the papers. I mean, overall we had 67 papers, and some of them, let's say around 20, report accuracy values, and 8 of them have accuracy of 80%. So we are also have a reasonable accuracy compared to other studies done in that field. Also, I want to mention our study was the first one that has been done on test case dependency analysis for natural language requirements. I mean, there are studies for unit tests, but in our set of the 67 papers, there are no approaches for test case dependency analysis. These are more approaches for test case generation and so on. Yeah, but still, yes, this gives an indication that the accuracy values are reasonable here. Okay, given that, I want to summarize that. So what we did is we automated the dependency detection between system test cases based on natural language processing. We applied 2 clustering algorithms, HTTP scan and fuzzy semi clustering, and the HTTP scan performed better and achieved an accuracy level of 80%. And what is the value of the approach? The approach can, I mean, it shows that the approach works reasonably well in the following sense. If you have a set of test cases, you take that set, you apply our natural language processing approach, this doc2vec, and then the clustering, and then you get a good estimate for the dependencies between test cases, which allows you to actually steer your test case selection and prioritization strategy. I mean, for sure, you can immediately ask, why have you taken these 2 clustering algorithms, the HTTP scan and the fuzzy semi clustering? Why have you taken cosine similarity and not another one like Q-grams or whatever? And this is actually ongoing work. I mean, we take more distance measures now, right? So Jacquard as well, Q-grams, and also more clustering algorithms, and figure out which one performs best in which context. So this gives our work more, let's say, more more solid machine learning basis, to actually figure out which approaches are then the most suitable ones. Okay, and finally, I want to highlight that I think this topic in general has a high potential, right? Applying natural language processing to requirements verification and validation problems. And I think there even is a new layer upcoming, right? Namely, to not only use the natural language processing for testing problems, but also to use it for extracting suitable requirements, right? And then because the requirements are always the basis for the system level testing, and in the more fussy the area becomes, like AI systems, right? The more uncertain these systems become, the more important it is to get a solid base of requirements. And I see also potential to apply natural language processing approaches to retrieve requirements, especially also for AI properties, right? There is this, for instance, this AI trustworthiness categories like fairness, safety, robustness, privacy, and so on, to extract requirements from standards, or at least semi-automatically, right? To take that as a basis to formulate requirements and to then do the testing assurance based on that. I think that's also an important area of future work. Okay, then finally here we can see the references that were underlying my presentation, and with that I want to close and thank you for your attention.
So thank you so much, Michael, for your very interesting talk. Okay, so this talk actually gives us a very good idea about that how natural language processing has been till now applied, and how related to use of POS tags and some other kind of stemming and so on, related to the SLR, and then related to system verification. So I have some questions. So before I actually go with some questions, so I actually have the questions from the audience if someone has the questions.
How should we ask questions, by the way, through the chat or audio?
No, you can ask. You can actually ask by unmuting yourself. So there is no problem with that. Yeah.
Okay, so thank you for this very interesting talk, Michael. And I have a question about the analysis of test dependency for industrial systems like train systems that we are considering. The case where you have, well, the impact of dependency analysis, as you showed with the example from 45 to 5 hours, seems to imply that failures in testing would be common. Yet, my impression would be that in most cases, for mature systems, most tests would go correctly. So, were you working on, let us say, preliminary development, or what was basically the
you're right. These were actually systems that were under development, right? So and for that purpose it was, let's say, not there were still some faults included, right? But you may be right, in many situations you don't apply the test cases for the purpose of finding faults, but just of be assured that there are no faults, right? That is actually true, but still, I mean, you could let's say, I motivated dependency from that perspective, but you could define dependency also differently, right? So you could also, you may have the situation that you have a large set of test cases, and some of them are really functionally dependent. This means, in the sense, if something works, then you can assume that another functionality works as well, right? Without immediately linking it to faultiness. Then you could even then it could even be helpful on that basis, or even to identify test cases that are very close to each other, right? That you can group them together, or you can even use it to distribute who should execute the tests. So you can use it, or you can reframe it a bit differently as well. Yeah, I would say that could also be a way to apply the approach.
Yeah. So any other questions, anyone?
Yes, Saurav, I want to ask something.
Yeah.
Okay. Hello, Michael.
Hello.
It was a wonderful presentation and gave us an idea to go deep inside the cluster-based test scheduling strategies. So as you told us that your clustering is giving 80% accurate results. So my question is, as we know that k-means is the most widely used clustering algorithm and with proven results. So have you also tried other clustering algorithms such as fuzzy, c-means, k-means? Or do you think that your results would be better in case you would have used k-means, or the results would not be as good as your results are showing here by using your SDB scan? So this is what.
Yeah. K-means, I mean, fuzzy mean is, let's say, an extension of it, right? That we found more suitable in our context. And actually, you see, we are also trying out other approaches. Affinity, agglomerative, TP scan, HEP scan, and spectral clustering approaches. And this is still working in progress, but you can see that the setting is quite diverse, right? Which one performs best, right? And from that perspective, I think we still have to dig a bit deeper to understand properly the reasons and give some guidance. I think that could be then software engineering output to really provide some guidance for how to apply and which approach to apply in specific settings, right? Yeah. So, but I think this is not the end of the story. There can be done. You can do better. But I think that's with machine learning, that's always the case, right? You can tweak and play around a lot to get to optimize it for specific settings.
Yeah. Thank you so much.
Thank you.
Yeah. So, any other questions? Yeah. So I think Michael, I have some general questions. Okay, not related to this specific topic. So when we are actually talking about the natural language processing, the parser is playing a very important role. So typically, the efficiency of the parser is very much important, because whether we use any kind of parser, whether it is related to Stanford or maybe any other parser, the efficiency plays a very big important role. That is first question. And then how you in your opinion we can actually limit or maybe put some kind of constraints on the or maybe related to the process, how we can negotiate or maybe remove the efficiency of the parser. Next question is that when we are dealing with the natural language processing, then if we take only the natural language text, then definitely processing the natural language is typically very difficult when we use some kind of parser. So is it mandatory or is it required that we have some kind of intermediate translation, so that from requirements that is a unstructured, or you can say that in a typical English related format, to some kind of a structured format, and then later we can use it for the processing. So,
Yeah, I think
your comments on these two questions.
Yeah, I think in general, what helps a lot is having also domain concept, having taxonomies that you can link your actual extracted text flavors to, right? I think that's very important. So having let's say having a general meta model of concepts, like how a test case should look like, as well as having domain-specific taxonomies of concepts where you can match your text fragments to. I think that's a very important aspect. I mean, we have not considered that, but I have been involved in other work where it's more about regulatory compliance, and there we actually rely on a domain concept taxonomy, right? So That's definitely an important issue. Mm-hmm.
Okay. So thank you, Michael. So do anyone has any other questions to Michael? You want to ask or you want to discuss anything with Michael? So I think anyone? Yeah, so I think Michael, no one has any questions. So I really thank you for accepting our invitation and has a talk here in NPS 20.
Yeah, thank you very much for having me. It was a great pleasure and honor for me to be invited to this to this workshop. Yeah, and I look forward. I will partially also attend the remaining workshop and look forward to the discussions.
Yeah, of course. Thank you, Michael. Thank you so
Thank
much.
you.
So everyone, please, if you have any questions afterwards, then you can write your questions on the chat or anything else.
Sure.
Michael will definitely help you to answer such questions. Okay. So thank you again, Michael. Thank you so much. Yeah, so I think we have the next. So now we have accepted 3 papers in our workshop. So we are going to have the paper presentations, and then in between presentations or after the presentation, we have the discussions on the paper as well. So we have the first presentation, okay, which is from Kayasi Hanayama. And then the topic of the talk is humpback code completion system for Dockerfile based on language model. So I actually request Kayasi to please.
Yes.
Yeah.
All right. Can you hear me? See the slides?
Yeah.
Yes. Okay. Okay. Now, start my presentation. Thank you for introduction. I'm happy to be here. I'm Kaisei Hanayama from Osaka University, Japan. I'd like to talk about my position paper entitled Humpback Code Completion System for Dockerfile based on language models. First of all, I'd like to explain about Docker as a prerequisite for study. All right. The Docker is a platform for containerized virtualization, one of the server virtualization technology. In Docker, logical compartments, containers, are created on the host OS, and each container provides its environment. Docker is the de facto standard for containerized virtualization, and according to a survey, 87% of IT companies are using it. The benefits of using Docker include lightweight processing, improving portability, and the ability to configure the infrastructure as code explicitly. Let me explain this point in more detail. And when creating containers in Docker, we write definition files called Dockerfile. Base images, which includes Linux distributions, are specified by from instruction. The commands to be executed in container are defined by run instruction, and the publish support by expose instruction, and so on. By describing the state of the container through imperative instructions like this, we can build the desired container. So this practice of infrastructure configuration is called infrastructure as code, or IAC for short. By automating infrastructure management, IAC guarantees to get the same results no matter by who or at when or how many times you run it. Docker is which organizes containers as code can be said to part of the IAC element. So, the advantages of using IAC include preventing human errors by reusing existing knowledge and reducing management costs by automating infrastructure configuration and incorporating knowledge gained from conventional software development. However, Docker and IAC are relatively new technologies, and some areas are still in progress. I mentioned earlier that the know-how of software development could be incorporated into infrastructure configuration, but many aspects haven't been introduced, such as development support and static analysis. So in this study, we focus on code completion in such fields. Code completion is a fundamental feature of development support and is frequently used in editors and IDEs. It is known that developers use code completion frequently, as much as several times a minute. As we saw earlier, containers in Docker are created by writing configuration scripts in the Docker file. So we think it is possible to build a code completion system for Docker file too. So the purpose of this study is to build a fast and accurate code completion system for Docker files. This system helps reduction of typos and allowing the reuse of existing knowledge. Besides, statistically processing the pre-collected Docker files enables it to make contextual predictions and improving development efficiency. As an implementation of this system, LSTM is employed to generate the candidate language models, also to overcome the Docker-specific problem and improve the system's accuracy. We devised a solution called model stitching. I'll explain these points in detail later. So let's start with an explanation of the language models. When word sequences are inputted, language models calculate the occurrence probability of the word sequence. In other words, this probability represents the naturalness of the word sequence. For example, suppose you choose a word that follows I am a, from, cat, or cats. Of course, for we humans, the naturalness of the sentence I am a cat is intuitively obvious. The language model calculates the probability of sentences I am a cat and I am a cat. If probability for the upper sentence I am a cat is 0.823 and the lower sentence I am a cat is 0.014, we can objectively confirm that the upper sentence is more natural. So our idea for code completion is generating candidate words taking into account these probabilities. I mean, what word is most likely to be selected next for the input word or code sequence. There are several types of language models, including Ngram and Transformer, BERT, GPT, and we use long short-term memory, LSTM, in this study. Before explaining about LSTM, I'd like to explain about the recurrent neural network, or RNN. Neural network is a mathematical model that mimics part of the brain and provides some kind of output to input. This is the feed-forward model. And RNN is an architecture that gives feedback from output to input to neural network. By providing this feedback, RNN can handle time series data. In this research, we realize a code completion system by treating the contents of Docker files as time series data. LSTM is an RNN architecture that replaces the middle layer of RNN called LSTM blocks. For time constraints, I don't go into details, but it is possible to learn long-term dependencies. Okay, now let me explain about our proposed method. The generation of training data involves search, collection, and division procedure. First, use the GitHub API to search for repositories that contain Docker files. Next, pull those repositories and extract the Docker files only. Finally, the contents of Docker files are broken down into word sequences that are easy for the learner to interpret. So this division procedure is explained in more detail with an example. Let's assume that we get a simple Docker file like this. First, we split the contents of Docker files into word sequences, and the input is paired with expected output. For example, from is paired with CentOS and from CentOS with run. Next, these training data are encoded with integer values so that the learner can easily interpret them. Finally, the number of elements in the training data varies. Therefore, zero padding is performed to obtain fixed length data. After creating this data, LSTM is trained by this training data and generate language models. We used Python to implement LSTM. Three libraries or frameworks are used to implement, namely TensorFlow, Keras, and Optuna. By the procedures described so far, it is possible to build code completion systems, but these are the general purpose methods, no Dockerness. I mean, code completion systems for any language can be built by doing the same thing without targeting Docker. So we introduced an idea called model switching. Model switching solves Docker-specific problems and improves the accuracy of the Docker-specific code completion system. So what is the problem? What is the Docker-specific problem? We have found a problem with the base image. As we saw earlier, base image is an image file on which containers are created, including a Linux distribution. Then, what is the problem of the base image? Docker files can have a nested language. I mean, embedded scripting languages, mainly Bash, are described in a nested state, so the contents of Docker files greatly differ depending on the base image. Thus, the base image's differences should be considered to realize high accuracy code completion system. That's where the model switch comes in. Model switch is a practice to change the language model for prediction according to the base image of the input Docker files. For example, if the base image of the input Docker file is CentOS, the language model trained by Docker file, whose base images are CentOS, is used for prediction. Of course, it does the same for other Linux distributions like Ubuntu or Debian. So now I'd like to give you a quick demonstration. We have created a code completion system, Humpback, that implements the proposed method. Humpback is available online and can be used in a web browser, no setup required. So this URL is listed in our paper, so please feel free to try it. To present how Humpback's code completion works, I've prepared two kinds of demos. Now I switch the screen. Can you see the web browsers here? Give me some reactions, please.
Yes, we can see.
Yes, okay, thanks. Okay. All right, the left side of the screen is Humpback, and on the right side is an example Docker file. First, imagine a scenario where you want to write this Docker file. Right, as you start typing letters, Humpback immediately presents candidate words. And OSL, right. You can select the input words from the provided list. If you want to make a prediction at any point in time, you can do so with Ctrl plus space or Command plus space. Right now, run is followed by yum, then -y, and install and httpd. So this line could be typed almost exclusively with Humpback's prediction. After the expose instruction and make a prediction again, so the first candidate word is correct here as well. So you can confirm that Humpback's predictions are so accurate that some descriptions can be entered using only candidate words. All right, now I'd like to show what happens to the predictions with different base images. All right, again, after typing CentOS, you will see a yum like this. Or if you change to another Linux distributions like Ubuntu, you will see the candidate words are changed according to the base image. Or if you change to another Linux distribution like Alpine, you will see the candidate words are changed again. So you can see that candidate words are changed with differences in the base image. All right, and now back to the slides. Okay, we conducted evaluation experiments to check the following points: how accurate Humpback is, and does the model switching work? The experimental procedure is as follows. First, extract 100 Docker files from the dataset, and second, set the correct answer to a random position in each Docker file. Third, the contents from beginning to just before the correct answer are given to language models and generate candidate words. Finally, correct answer and candidate words are compared and to calculate the accuracy. So we performed 10 rounds of the above process. This table shows the average top 1 accuracy, which means the percentage that both candidate word is the same as the correct answer. We compared 3 major Linux distributions in the dataset, namely Alpine, Debian, and Ubuntu. For the case without model switching, we created a generic model that was trained with all Docker files. In the table, J means that generic model and hump means our proposed method, humpback. And delta is improvement score, the difference between Jen and hump. As we can see, prediction with humpback is more accurate for all conditions. There are no cases of worsened accuracy, and humpback's accuracy is 96.9% on average, up to 98.8%. As I mentioned earlier, in the demonstration, the candidate words are presented instantly. So with its quickness and high accuracy, we believe that humpback can improve productivity for Docker file. All right, here I conclude my presentation. We propose humpback, a code completion system for Docker files. Humpback is available online and can be used in a web browser. Variation experiments show that humpback has a high average accuracy of 96.9%. And we also model switching to overcome Docker-specific problem, the base images differences, and it proved to be effective. As future works, we will further improve the accuracy of humpback and compare it with other code completion systems. All right, this is the end of my presentation. Thank you for listening, and any questions?
Thank you. Thank you so much for your presentation.
Yes.
So we have one question from one of the author. He asked that, is your proposed method able to learn from recurring command used within a team project, or is it trained once for all? So that was the question asked by one of the author.
I'm sorry. Can you speak more easy?
Okay. So the question was, your proposed model, will it be able to learn from recurring commands within a team or project, or is it like it is trained once for all? The question also written in the comment in the chat section, so you can read from the chat section also. The author wrote that question.
The question is how to learn the training model or the whole dataset or the code snippet. This is the question, right?
Right.
Yes. We changed the slides. Right, we collect the Docker files and put the repositories and extract only Docker files first. And the division procedure is executed on the whole data set. And the training data of length of training data are fixed by 10. And the training is conducted by five how can I say? So if we collect Docker files here and the learning phase is conducted to the whole dataset. If we can collect the Docker file here, this is the answer.
No problem. Okay, so I think one of your co-author wrote the answer in the chat section. So we got the answer like I trained once for all. So if anyone is having any other question, then you can ask. The house is open for any question.
If the learning is finished and we do not conduct the learning phase, so we once learn and generate language models. So the training phase is just 1 minute, one time.
Okay. No
Okay.
problem.
All right,
Okay.
thank you. And if any questions, please feel free to mail me, so we answer it.
Okay, that also fine.
Okay,
So
thank you.
thank you so much to present your work. Thank you so much. Thank you.
All
So
right,
I
thank
can, Dr. Saurabh can take the stage now.
Yeah, so I think we have now we have the next presentation. Okay, so next presentation is by yeah. So thank you, Kayasi, for your presentation. So I
Yes,
think
thank you.
we can move forward. Yeah. So next we have a presentation from Fabian Gilson. Okay, so they are actually the three authors. That is Fabian Gilson, Sam Anand, and Jack Steed. So Fabian is presenting his work, and the title of his work is Recording Software Design Decisions on the Fly. Okay, so I actually request Fabian to please share his screen and have his interesting presentations about the uh, software design decisions, how they can record.
Thank you. Just switching. Hopefully you see. Yeah, my apologies. The WebEx is not my. Yeah, it works. It's not my favorite tool. Okay, can you hear me well?
Yeah, of course. Good.
Cool. I'm working on this project with Sam and Jack, but I'm working in NLP related things with quite a few other colleagues here at the University of Canterbury. This is probably the less advanced NLP work I'm doing at the moment, but it's a work in progress too. So basically, the context of this project is recognizing that developing a software is collaborative. So you have many people at the same time discussing about potential solutions, discussing about potential frameworks, potential design decisions, and the decision-taking mechanism is highly collaborative. So basically, how it works in a agile software development context, a typical agile software development context, is that you will have a few people discussing during the planning, and then based on the selected stories, for example, they will start looking into the stories and going into planning 2, where they frame more into details what will be developed during a sprint or during the next task to be done if you're doing Kanban, for example. And then you have someone starting to put the tasks that need to be done to be put on the agile board, and then you working on it. And then as always, as you work on stuff, then you start seeing that you made mistakes, you didn't take the right decisions, and then you need to sometimes come back to the drawing or the whiteboard to make sure that you to find the right solution. And then you come back into your desk and you continue to code, you update your program. And sometimes you need to create new tasks. So you go to your agile board because you need to trace what is going on. Usually it's based on policy. But actually, no, you're not doing that. So you're not updating the tasks, you're not updating the decisions, you're not updating the documentation because you are stressed by delivering the thing. So you try to plan, even in Agile, you try to plan a little, but at some point you stop doing the document and you don't update your decisions. And more, we're using tools like Slack, Teams, WebEx, and we discuss on these tools. And then, so because we have all these communication channels, and we are also using these kind of things very quick to answer questions, even at 10:30 in the night, like here in New Zealand, you're still working at that time. So you use all these tools to do that. And in software engineering, we try to solve every problem we have with a new tool. So we have Jira, SourceTree, Slack, Project, SonarQube. We have wikis, Visio to draw diagrams, Dropbox, GitLab. And yeah, it becomes a nightmare to remember where the decision has been recorded, if it has been recorded, where did we discuss about some problems, where did we discuss about some framework. It's just a nightmare. And if we start adding new tools onto that, developers just really get crazy. So the proposal here is to go into a just-in-time recording, trying to get closer to the developers. So if we look back into the literature, design decisions models is not really new. There is a very good paper from Bat and his colleagues. So it was part of his PhD thesis that he defended a few years ago, I think a couple of years ago, but the literature review has been published last year, well, beginning of this year, actually. So there are many models. Probably a Christian model, 4+1 view, maybe is done, the one we would use. So the way to formalize decisions. There are also a few techniques where decisions into the code have been formalized into transformations. We did some work previously in that area where every decision into the code or into the architecture model was written in terms of model transformation. These techniques are very, very usually used on top of on the tools of people. So at some point they just stop using these tools. At the opposite, people try to do some mining. So there are manual techniques that are actually coming from even the 90s. Problem with manual techniques is if you need to record decisions and look into the code to extract the decisions, it takes a lot of time. And you're never sure that what you are documenting is actually the right decision. There are also a few automated techniques where they mine the source code, trying to retrieve into the comments, or trying to retrieve into the tickets in an agile board, trying to mine the decisions in terms of selected framework, design pattern, and these kind of things. But again, these mining techniques, like the automated ones, they are using machine learning techniques, and the problem is that if you input into the machine learning technique garbage, then you will have garbage decisions at the end, and you will spend a lot of time into looking into these decisions and actually not getting any value out of this mining retrospective. So we try to model design decisions using a simplistic model where we have 1, 2, 3, 4, 5 sections into a decision. So basically, this has been defined to have a way to record the decision very simplistically for practitioners. Student Al did define that. It's pretty easy. You define the context, you define requirements, what kind of option did you select, what did you neglect it, and why did you take this decision, hence this Y shape. So we did a first attempt in formalizing this this decision model into a real mineable relational model. So you retrieve in this model every single element that was in the Y model, and I tried to make it almost looking the same shape. So you have the design decision, which is composed by a context, the concerns, the option, the consequences, and the attributes, the quality attributes of this decision. We added into this model some metadata because usually it's important to know about a decision, but it's also very important to know about who took that decision and who was involved into the decision process, because sometimes everything is not written clearly, and we still need to keep the link to the person that took the decision. A lot of things and a lot of knowledge is still in the head of developers, so we don't want to replace that. We want to make it simple enough for people to use it. So we actually tried the first failure of this tool. So we decided to use the full template as is and to have developers to record this full sentence that would look like this huge grayish sentence. And when we started having users playing with the tool, this is basically what we got. You are simply breaking every single usability rule and user friendliness rule about using tools. So it's one of the professor here, which is a sort of a Jedi master in HCI, so Andy Coburn. I was pretty annoyed by the tool we developed. So we came back, as in my first slide, we came back to the whiteboard and we tried to make it differently. So from the bot, the first bot tool that we created a chatbot. So you started to record a decision by invoking the bot, and then you pass incrementally each part of the decision to the bot, and the bot each time will record or augment the decision model that it's creating based on the model I showed just before. And when you actually confirm the decision, then it is persisted into database and extracted, pushed into a wiki in the form of a markdown page, which can be browsable after. So usually it's easy to just have a wiki next to your code. So it's easy to, you can talk to the bot to retrieve decisions, but you can also browse into the wiki next to your code. So for example, you can just download the wiki in a text-based fashion into your terminal-based system without requiring some sort of GUI to look after decisions. So the implementation of this is a command-based bot in Slack. And then you can just simply initiate the recording command with a dedicated command. We have only two parts which are compulsory, which is the context and the option, the selected option of the decision. And then you can also optionally pass neglected options to concern the quality and the consequences. Decisions, as I said, are persisted and output to a wiki, and you can search decisions at present time. So, for example, as I will explain after, the bot is still a very early prototype, so we cannot do advanced change into existing decisions, but still, it's a first step. So let me try to share a quick demo. Yeah, found it. Okay, looks like it works. Let me start. Maybe. Yes. So as you can see, as you can see, it's about where you can start by initiating the command. You pass the various attributes to the bot, so you can pass every single element every time separately, and then every time you pass something, the bot confirms with the missing parts. If you make a mistake, you can pass again the same element to the decision. So, for example, you can pass multiple times a consequence, and then it will override what's happening into the decision. And then you can confirm. When it's confirmed, you see it was a blank wiki. If you refresh, then you can see that it has been serialized into the wiki. So you can pass a second decision, and it's just to show that you can only pass a few elements. So I recall it's only the context and the option, which are mandatory. Any single other element are optional. And then, as you will see, we can pass, for example, when we select the option hibernate, then we can say that it has many qualities, and we separate the qualities by commas, and then it will create different qualities, different elements of qualities, as we will see in a second. So as you can see, there are a few different qualities, so they have been listed separately. And normally soon we will see that we can search for existing decisions. So in the wiki, it's not shown in the full demonstration, but I've added another decision which is linked to the same authentication element. So you see that we can retrieve the decisions. And if you don't pass, let me come back here. If you don't pass any let's go back to, yep. If you don't pass any keyword, then you can retrieve all decisions. So we applied a quick heuristics-based analysis to the bot to make sure that this time we were developing some sort of usable bot. So we decided to make it conversation-like. So it's not completely, as you could see, we need to pass commands separately to the bot to record each part. So it's not really a discussion. It's more like a one-way feedback, but it's still an improvement from earlier. We use the user's language. Only the first command needs to be remembered to start recording. The others are always repeated to the user. The wording is consistent and fits to Slack. So the commands use the slash, like all Slack commands. So every time you type something, the bot explain you what you need to what you can pass on top of your decision. If you don't pass compulsory elements, the bot will tell you also. There are two ways of interaction. So the big sentence I showed a bit earlier, you can still use that if you are really used to the system. And we have a bit of document with the README. So to wrap up, so we created a chatbot-like system to record design decisions on the fly as you are talking with your teammates in a Slack channel. So for example, someone may initiate when you are in the channel, someone may initiate the transaction with the bot, and any single participant in the channel may add his own bit to the decision. So we want to get inside developers' everyday tool instead of adding a new tool, and we make it searchable and interfaceable. So at the moment, it's pretty rough. So we moved away from a very natural language processing heavy system with the long sentences to a very simplistic one. And now we will try to come back to and add more NLP features into the bot to ultimately see how transparent we can create the bot. So we want to ultimately make it completely transparent and actually being able to monitor the discussions within Slack to see if people are actually taking decisions or if people are taking decisions which are not compliant to existing decisions in the database. So this ends my talk. Any questions, feel free to ask now, or flick me an email, or look into the code, the repository that's shown here. And also in the paper is open. And yep, any questions to ask?
Thank you, Fabian, for your wonderful presentation. So if anyone from the audience want to ask anything, HT time is house is open for any questions.
Yes, so Fabian, there is a one question in the chat window, okay, by one of the participant that integrating the system into Slack seems very interesting. So how to evaluate the system as an academic paper? So in his opinion, designing such kind of tool is very hard to evaluate. So how to show your formal model is sufficient or not? So how you can actually explain about your formal model?
Well, if I get the question right, there are two questions in that one. So the easiest one is how to show your formal model is sufficient or not.
Mm-hmm.
So the Y model we use is actually a summary from literature. So if Shinsuke is interested into looking into that, the paper from that that I'm citing here from 2020 is very interesting because it is summarizing a lot of existing works. And these 5 elements are really the core of design decisions. So we don't want to, so obviously, we currently have a few missing things. For example, we don't create links between decisions. Okay. So there are, if you look into the ontology of Pushton, they create conflicting decisions, refinement decisions. So there are links between decisions. At present time, we don't have that. Because we don't want to make the system too overwhelming, and we want to see how NLP may help to actually look into these links for the users. How to evaluate the system? There are a few things you can do. The first thing we are looking to doing is to involve the industry and having a task-based evaluation with a something like a think aloud protocol where you present the tool to people and then you have to follow some sort of protocol, and then you see how they deal with the tool, if they are missing something in the recording of decisions, if they find it complicated. So to me, the first step is to really see if there is an interest and if there are usability problems in the tool at the moment. And then we will try to expand maybe with a more complex decision model or with a more complex set of features.
Okay, so another question that I want to ask you is that currently there are some predefined tags people are using. So is there any way means we can overcome this part, or we can make it more fluent to other people?
Yes, so this is the idea goal. So this is the graal from this project. So we took a very optimistic approach at the beginning with having not too constrained sentences and see how the NLP. So we were using SPACE, how SPACE was able in some sort of predefined keywords at some point, but seeing how SPACE was able to cut and give us some sort of graph that we could use to recreate the model after. It was a usability failure and it was a technical failure because the slightest variation in the way people were talking, and in the Slack channel, people don't always use pronouns, prepositions, they type fast, they don't have commas put at the right places. So results were just garbage. It didn't work. So I think we need to create some sort of restrictions in some ways where people will need to at least tell the bot that something is happening or something happened, and having them probably having them acknowledging or correcting the bot as they talk. But a fully transparent thing with the results we've had so far, I don't think we'll be able to do it with the current technologies and NLP technologies that we have.
Okay, that's okay. So any other question? I guess not. So thank you so much for this presentation. And
thank you.
Okay, thank you so much. We can now have the another presentation by the. So the just a minute. So the next presentation is on the topic which is reducing regression test suits using Word2Vec natural language processing tool by Bahari, Ronald, and other co-authors. So can we have Bahari here to present the work? Can we have him? Okay, just a minute. Okay, so I am just contacting the author. It may take a minute or so, and I think then he will be available. Okay, so he is already here. Yes, great.
We cannot hear you, Bari. We cannot hear you. Yeah.
I think he is setting it up.
No, no.
Okay, now it's okay.
Yeah, yeah.
Yeah, it's okay. Good. Okay.
Okay, so please continue. Yes.
Okay, let's start. Today I'm going to present our study. The title is Reducing Regression Test Suite Using the Word2Vec Natural Language Processing Tool. My name is Bahar Afshinpour, and I'm a PhD student at University Grenoble-Alpes in France. Let's get started by software testing. Software testing is one of the time-consuming and highly priced steps during the software development, especially for a large system. It accounts more than 52% of total software development budget. It's possible to detect faults by analyze the user logs, process user logs as a test suite, because log files can reveal faults. But log files are sometimes huge. they record of weeks and months. So rerunning an entire log files is highly time consuming. Can we make a log file smaller while the same log file still reveals the same file? We must select important event and discard the rest of events. There are other methods for clustering traces and test suite reductions, but generally they focus on the combination of the selected events. They don't consider semantic of events in log files. We proposed an NLP-based approach. Dr. Michel used NLP for produce software artifact log test suites. But our work is reverse. We process software outputs using NLP. We consider combination and semantically similarity of the events, traces of action in log file could be regarded as a sentence of words in NLP. This is our overview of my talk. First, I start software under test. We have a scanner case study. It has a large file from clients or customers' behavior. There are some files in the software code. The goal is select customer that their behavior trigger faults. And interest is clustering user behavior in order to find outliers, find unusual behavior. And so after finding unusual behavior, we can reduce the test suites. A scanner is a device, as you can see here, depicted here is a scanner. It's a device used for self-service checkout in supermarket. The customer scan barcodes and maybe delete some barcodes, and there's some actions I explain in the next slide. This scanner system has a Java implementation, but we need a buggy software to evaluate the proposed test suite reduction method. So to artificially inject faults, the source code of scan software was mutated. There are some bugs or mutation injected on. This is an example of log files. As you can see here, there's some columns, session ID, objects, actions, input parameters, and outputs. The shopping process starts when customers unlock the scanner. Later, for example, for client 6, later he may scan the items, and maybe he want to decide to delete this item and put them back in their shelves, and there is some another actions that can do. And finally, he refers to the checkout machine for payments. For each client, there are a series of actions. It starts from unlock to pays related to each customers. So we want to reduce these test suite files and remove some sessions or clients that unimportant. The session is the sequence start from unlock to pay. Okay, we have created 3 test suite, 126 event, 100,043 events, and 200,035 events. They include shopping step of different customers. As you can see here, these test suites enter as input to scanner software, and the result is how many mutants have been killed. If a test suite can find the injected fault, we say it kills the mutants. As you can see here in this table, there are some information about these three files. For example, in the first row, you can see for 126 events, the number of clients is 61, the number of events, and this test suite can kill 19 mutants. And the other two test suites can kill 22 or 23 mutants. We want to reduce these files. Okay, for purpose method, we follow these steps to reduce the test suite. The first step, we vectorize the events, then we create a word-to-vec model, and we want to find a measure for compare these sessions or sequence. We use averaging method. And after, for clustering, we use k-means, employ elbow method and TSNE. And then finally, we select one customers or session from each cluster. The first step for vectorizations, we decided to differentiate among similar actions which have different inputs and outputs. In order to process the event, we need to vectorize them. So some important items is actions, input parameters, and output. We have a set of actions, input parameters, and output. For example, for set A, there is unlock, abandon, transmit, scan, and something like that. For input parameters, we have some barcodes, we have some value for pay, and for output, we have some value, for example, 0, -2, and another value. As you can see here, for example, for this file, we want to code the first row. As you can see, action is abandon. The index of abandon in set A is 3. The index of input parameter in set P is 0, nothing, because for this row is nothing for input parameter. And the index of output also is 0. So we can code this row as a triplet, 3, 0, 0. We continue to code another rows, and so we can code every line, every event of the test suite to the triplet. As you can see here, for example, client 23 has this sequence. So every client has a sequence of triplet that this is related to actions the client do during the shopping. So we want to clustering different sessions or customers. For this, we need the method to say if this client are in the same cluster or not. We use word-to-vec modeling. Word-to-vec is a word embedding technique. Use deep learning and neural network, convert words into vectors. It's trained to predict a target word from the context of its neighbors. So at the end, semantically similar words have closed vector. We're looking for finding similar vector representation for action that occur in the same event. For our case, each triplet in a session in a vocab for word-to-vec model. We store each triplet as a string. We treat triplets like words in natural language processing. As you can see here, each triplet refers as a one vocab. We use GenSim library, and for example, for 126 events, we convert each triplet to the word-to-vec vector. For example, the triplet 000 convert to this word-to-vec vector, and triplet 110 convert to this triplet. In this table, you can see the number of different triplets related to each files. It's important, the dimension of word-to-vec are equal to number of vocabs. So, for example, for this file 126, the dimension of the word vector is 15. So there is 15 elements in the vector. Now we want to averaging of word-to-vec because we need a measure for each sessions or sentence we want to compare. Because of this, we average the word-to-vec vector for each session. As you can see here for client 60, for each triplet, we have a word-to-vec vector, and so we use averaging and find one vector referred to this, represent this client. So now we have a measure for each session. We can compare this vector. In the next step, we use TSNE and k-means clustering. Because the dimension of word-to-vec is high, use TSNE. TSNE is a non-linear dimensional reduction technique. It's extensively applied for image processing, NLP, speech processing. It is technique for visualizing, also visualizing a high dimensional space. As you can see here, for 126 event, we plot 61 client in this picture, use TSNE, and we can see and we can be cluster, as you can see here. We use k-means clustering. Because k-means need to know number of clusters, we employ elbow method to find the optimal case. And for example, for 126 events, we employ elbow and find k between 6 till 10 is good for this data. And for example, for k equals 7, we can cluster, as you can see here. We choose, for example, cluster 4 here. You can see the session or client 2, client 6, client 29 related to this cluster. As you can see here, there is a similarity between the sequence. And also, we check the set of mutants that this client can kill. There are similarity between this set of mutants also. That's a good. And the final step, now we want to reduce test suite. Just we cluster them. Now we choose the longest session from each cluster. So we can reduce the file. We will have cost-selected sessions. As you can see for this example, for cluster 3, for example, client 30 is the longest one. As can expected, this client can kill the longest set of mutants. And for the result, here we explain the result. It can be seen that when k equal to 2 session chosen from 2 clusters, session 30 from cluster 1, session 24 from cluster 2, but they can kill only 9 mutants. But for k equal 10, there is a 10 session or client from 10 clusters, and it can kill 19 mutants that the original test suite can kill, but it needs only 194 events. So we can reduce 126 events to 1026 events to 194 events. The same result for 2 other test suites, as you can see here. For example, for 100,043 events, we can reduce the events to 167 events with select K, with choosing K18. And we can kill 22 mutants that the original one can. And also, this result for 200,035 events, and the number of events reduced to 1,111 by choosing 73 clusters. And for conclusion, applying word-to-vec and vectorizing customer sessions is effective. And word-to-vec clustering separates sessions that kill similar mutants. By choosing the longest session from each cluster, we succeed to kill the same mutants killed by entire test suites. For the future work, we want to find the concept space for event in order to have a more meaningful result. And for example, we just using k-means, applying k-means, but in future we want to using spectral clustering instead of k-means. And there can be many redundant events that could be removed. We are developing and analysis of a relation between events that can trigger a fault. Thank you for your attention. If you have any question.
Thank you for the presentation.
Okay.
Thank you. So there is one question from Fabian in the chat section. He said like which tool you use to generate the mutant actually. So you are generating some mutated code. So is there any tool you used to do so, or what process you follow, if you elaborate that?
Oh, yeah. There is another people in our teams that can produce and then create the bugs or mutation in the test suites. Yeah, and we use just the test suite and find some mutations. Yeah.
Okay, so I think
okay. Excuse me. I want to explain that this fault created manually by hand. Yeah, there is some tools to create automatically faults, but I just use some faults created by hand.
Okay, so
okay.
I think there are some follow-up questions also regarding to that. So they are, he asked that how confident are you about that mutants that they are basically representing the proxies to semantically equivalent test. Fine. So I think so you can look if you answer that question.
I cannot understand the question exactly.
Okay, so let me repeat it. How confident are you that mutants are representative proxies to semantically equivalent tests in real scenario?
Okay, there's some tools that can be find each clients or sessions kill which mutants. Okay, and after, for example. Here, after I cluster these sessions, I check that tools because I want to find experimentally if these clusters can kill the same or similarly kill mutant set. So I check experimentally behind the software and see yes this client can kill this set of mutants.
Okay, thank you. So any other question from anyone else? Anyone from the participants, or anyone can ask the question if you have any. Okay, I guess there is no further question. So Thank you so much for your presentation.
Okay, thank you.
Thank
If
you
you
so
have
much.
any question, you can send an email and you can refer to the paper. And there is more results for comparing the output using TSNE and without TSNE that you can find in the paper. Thank
Okay,
you.
fine,
Thank you
fine,
so much.
fine. Thank you. Thank you so much. I think now we have it's the time for next keynote talk. So we have with us Professor Fabiano Dalfis. He is going to deliver a keynote talk on the topic, which is NLP for requirement engineering, good enough. So let me introduce you the Professor Fabiano. He is currently working as an assistant professor in the Department of Information and Computing Sciences at Utrecht University in Netherlands. He is a principal investigator in the Department Requirement Engineering Lab. His research includes the use of AI with information visualization in order to increase the quality of the requirements engineering process and artifacts. He has devised software tools that assist human analysts and stakeholders in eliciting, expressing, and analyzing the requirement. So before joining the university in 2013, he was the postdoc researcher, postdoc fellow at the university as a Department of Computer Science, University of Toronto, Canada, and Department of Computer Science. And before that, he was at the Department of Information Technology and Computer Science, University of Trento, Italy. He has obtained his PhD in 2011 in the area of self-adaptive system, and his research is primarily funded by research funding agencies. For example, the PACES project was funded by the European Commission in the year 2016 to 18. He was the organization chair of REFSQ conference in 2018 and the editorial board and social media chair of the Requirement Engineering Journal. He is also the steering committee member of AIRE workshop. He regularly serves on program committee of international conferences such as RE, CAISE, AAMAS, etc. So let me hand over the stage to Professor Fabiano to give the talk. So, Professor, yes. So you can start your presentation.
Yeah, thank you very much, Santosh, for your nice words of introduction. I'm very honored to give this invited talk at this workshop. And the topic of my talk is indeed natural language processing for requirements engineering, and the provocative subtitle is good enough. And I'll be reflecting a bit on the experiences that I made over the past, I think, 6 or 7 years. All right, so let's make a short introduction about NLP for requirements engineering, or NLP for RE. On the left figure here, you can see a screenshot from a paper that we published about the current state of the art. And that paper is largely based on a sister, let's say, workshop to the present one, which is called NLP for RE, which is held at the REFSQ conference every year. So let's look into NLP for RE as a field. So why do we use NLP in requirements engineering? I guess compared to other phases of software engineering, textual notations are predominant in requirements engineering. And here are just a few examples of notations that can be used. Probably many of you know user stories. As a user, I want some feature so that I obtain something else. Or you may know the classic shall-based requirements, right? The system shall use cases as well. So even though there is some attempt to use models and formal specifications, the vast majority of practitioners in requirements engineering use textual notations. So no surprise that we have tools. But what are these tools? In 2012, Danbury and colleagues proposed a taxonomy of these tools. I'll go quickly over those so that you can get an idea about these tools. The first category is finding defects. So trying to understand what are the good practices that are not met when writing the requirements and highlighting those possible defects in the text. The second category is to take natural language requirements and to extract models, like a domain model or a business process model. Third category is about traceability, and in particular about inferring and maintaining trace links between natural language requirements and other artifacts from the software engineering discipline. And finally, the fourth major category is to identify glossary terms or other abstractions in natural language requirements. And this is a screenshot taken from a paper published by the group of Lionel Briand. So as you can see, these are four major categories. These are not the only categories that exist. And a recent survey conducted by Liping Zhao and colleagues has shown that there are at least 130 papers in the field of NLP for RE. And well, nevertheless, there are some problems with these tools that I'm going to talk about today. And in particular, today's quality will try to focus on the notion of quality. That's why I talk about good enough. I will take a personal perspective about within this presentation. And in particular, I'll be focusing quite a bit on the experience that we gained within the RE lab at Utrecht University in constructing and assessing NLP for RE tools. So in the next few slides, you're going to see some notes about the techniques that are behind these tools. I'm pretty sure many of you are aware with most of them. And then part of the talk, part of the slides will be about assessing whether these techniques actually work. And to do that, I will not cover all the tools that we built, but I'm going to focus on three exemplars. The first one is a paper of the first category that we've seen in Danbury's classification. And the tool is called Accusa. And the goal of the tool is to identify and highlight quality defects in user stories. The second tool belongs to the second category, and this starts from user stories and automatically extracts models. And this tool is called Visual Narrator. And the third tool is a mix of, let's say, the first category and I guess the second category, because it focuses on identifying terminological ambiguity in user stories. And the tool is called RevLite. As you can see, all the tools can be found, they are open source, and you're very welcome to use them. You're welcome to contribute to them, to adjust them, to adapt them. So let's get started. The first tool started our work on user stories, in which well, we wanted to figure out, okay, user stories are very, very commonly used in practice, but what does it mean to write a good user story? And here we have an example of a user story. As a student, I want to see the correct exam answers so that I can learn what errors I've made. And what we did in the work was we first conducted a linguistic analysis of thousands of user stories that we collected from industrial partners. Then, based on that, we assembled a quality framework called the Quality User Story Framework that has 13 criteria that a good user story should possess. And the first step was to develop the Accusa tool, and Accusa is using NLP to check parts of the Quality User Story Framework automatically. Some examples, I'm not going to go into the details, are identifying cases in which the requirement, the user story is not atomic. You can see the example at the top. and in particular here the indicator is the use of the AND word, where you have a requirement that requires two features, and that means it may be difficult to estimate how much it takes to implement it. The second example is a non-minimal user story, because instead of just having the as a, I want so that, it has two so that clauses. And the third one is not well formed because it misses the role. So the perspective, so the as a, the stakeholder who reaps the benefit when the requirement is implemented. So this is just very quickly what the tool does. It does a few more things, but that's pretty much what it does. And we first started as a classic in software engineering, taking some information retrieval metrics. We took 17 industrial data sets plus one that is publicly available. And our original goal for this tool was to have 100% recall. That starts from Dan Barry's 100% recall condition, where he argued that an NLP for RE tool that has to identify defects should make sure that all the defects are identified. It doesn't matter that much whether precision is not perfect, but when you know that all of them have been identified, then you know that in the worst case, you get some false positives, but you will not have to check all those that have not been identified. And the results? Well, we got 93% recall and precision 72%. So we didn't get to the 100%, but I must say that the owl here is very happy, and we were pretty satisfied with this kind of metric. But then, together with my former PhD student, Harm Lucassen, the first author of these papers, we wondered, well, what happens if we go to the software industry? And then we moved from information retrieval to an in vivo evaluation. And we conducted a longitudinal study in 3 companies for 2 months. So the companies, well, we actually monitored the sprints in the companies before the 2 months. Then we gave a training. We installed the Accusa tool, and we actually embedded it within their Jira environment. So when they were writing user stories in Jira, they would get comments automatically when the defects were identified. And the results, again, after the treatment was implemented, the quality of the user stories improved. So we were pretty happy. They were writing better user stories. On the other hand, we weren't that happy to see that project management metrics did not improve. We really wanted to be able to say, hey, we developed this technology, we are going to have improvements in the software projects. And we measured some metrics such as velocity, so how many user story points are implemented per period, and that didn't change. Also recidivism rate, so how many backlog items go back in the flow instead of going forward. That also didn't improve. And actually, there were much bigger events in the company rather than the introduction of our treatment. So as you can see here, we have mixed results. Let's move on now to the second case, which is the visual narrator. So now we take the user stories as an input, and we generate models, and these models represent the main entities and relationships that are mentioned in the user stories. And we proposed this technique in order for analysts to be able to identify conflicts between user stories, duplicate stories, incomplete requirements. So I give you a flavor of what visual narrator does, and then we're going to look again at the quality and if it's good enough. To build the tool, we did really a thorough study of the literature, and we found out a whole bunch of natural language processing heuristics to construct domain models starting from text. And we took some of them that applied to user stories. And to give you an idea of how this works, here we have a user story that says, as a visitor, I want to choose an event so that I can book a ticket for that event. And essentially, this leads to a domain model like the following. So visitor is recognized as an entity. Also event and ticket are recognized as entities, and the verbs that you can find, like choose and book, become relationships between the visitor, which is the stakeholder, and the entities. And the visual narrator does this not only for a user story, but goes through the whole collection of user stories. So you can imagine that the more user stories you process, the richer the model you get. So again, we wanted to figure out, does it work? Does it not work? And we obtained a few positive results from case studies with collaborating software companies in which we applied the tool on their data sets, we conducted interviews, and in particular, what we saw is that precision and recall were actually pretty good, around 90%. And also practitioners perceived the tool as being very useful, in particular for newcomers, so people who have just joined the team, and they really found that the visualization we have can be quite helpful for them to understand what are the major concepts that are used in the user stories. But we also faced a few problems there. First of all, and maybe the major issue was cognitive scalability. So we wanted to tackle one problem, which was how can you go through as a human in a large collection of user stories? And we ended up moving the cognitive scalability problem from the text to the models. So that didn't really help that much. And then getting maybe to a topic that is more central to this workshop, there were a few issues for us in using NLP heuristics and tool sets, how to handle with compound nouns. It's always very difficult for NLP tooling to understand exactly the semantics of a compound noun. And also sentences with multiple objects. So if you have something like, I want to send the report to the student, so you have both report and student as object. And then with a simple binary relationship between two entities, you cannot represent that. So we had to do a trade-off between simplicity and, let's say, how comprehensive our approach could be. Third exemplar is RevLite. And this focuses on the identification of terminological or lexical ambiguity. And we wanted to figure out what happens when you have quasi-synonyms in user stories. Why is this a problem? Well, you have two words, and you don't know as a developer if they really refer to the same entity or not. So do image gallery and gallery actually mean the same? Or can there be also video gallery, and then gallery is a superclass of image gallery? Of course, this makes a difference, because if you know that gallery and image gallery are different, then you may envision that there will be other types of galleries that may make you imagine, guess that there are other requirements that are not stated, or image and picture to view or to see. And the idea we had there was to combine semantic similarity and information visualization. And I think that is one perspective that I'll try to stress today. So on the one hand, there is the NLP tooling. On the other hand, you want to assist the analysts, and you want them to be able to see the outputs. And that is as important as showing the information retrieval metrics. So how does the tool work? We take as an input the models that are created by the visual narrator, and then we calculate pairwise a semantic similarity between the terms that we have identified, like gallery, image gallery, R, whatever. We use an off-the-shelf tool called cortical.io that uses a technique called semantic fingerprinting. I will not go into the details. We are just users of that technology. And if the similarity that is reported is above a certain threshold, we mark that as a possible ambiguity. And the output of RevLite looks like this. You have big circles. Each of them represents one stakeholder. So if you have the user stories and the user stories written starting with as a administrator, then you will have the concepts that are identified in those user stories within this circle here, the administrator circle. If the user story starts with as a user, it will be in the green circle, as a visitor in the blue circle, and so on and so forth. And of course, some terms are shared. That means they are represented from multiple perspectives. And well, there are multiple uses for this visualization, but what is important here are the red small circles, because those are concepts that are likely to be ambiguous. So there are very similar terms that are extracted. And I guess here there is, for instance, gallery and medium gallery that are very similar, and there is image as well. I will not go into the detail, but again, I want to focus on whether this is good enough. So this time we decided we wanted to do something a bit different, and we did a quasi-experiment against manual inspection. So we took 28 real-world data sets, so that is more than 2,000 requirements, and we had people trying to identify whether there would be ambiguity, both using RevLite and not using it. And the results of the approach were a bit disappointing. First off, especially if you set a time constraint, so if you say that the session lasts half an hour or something like that, manual inspection turned out to be better in terms of precision and recall than the use of RevLite. We could also figure out some of the reasons for that. One was that the participants had very high usability expectations, and we have a proof of concept tool. We didn't mean it to be a product, but still the users thought they wanted actually to have a product. And then the similarity algorithm, we use it's basically built on word embeddings, but the training is made on I think Wikipedia, and this doesn't have context information about the data sets that we have. A side comment that leads me to the next part of the talk is that reaching consensus on what is ambiguous was maybe the hardest problem we faced. So we thought it's very easy to calculate precision and recall, but it actually turned out very problematic to tell whether a couple of terms would be ambiguous or not. This brings me to another aspect of quality. So we have seen a bit of our experience on building and assessing NLP4RE tools, but another question is, well, in many of these cases, what we have is a gold standard. That means a manually annotated corpus that serves as the oracle against which we compare our NLP4RE tools, or also our NLP4SE tools. And what is the problem? Let me exemplify this using a different setting. As you know, well, app stores allow people to express reviews, right? And reviews are a rich source of feedback for app developers. They can describe bugs, feature requests, a lot of things. However, user reviews are challenging to process automatically via NLP tools. In the first place, there is a lot of spam and reviews that are probably not meaningful at all. Second, punctuation is hardly used and the language use is very poor. So, you know, people use slang, don't form complete sentences and so on and so forth. And finally, there is a lot of implicit knowledge, meaning that the person who writes the review is maybe just frustrated with experience with an app, and then he or she doesn't say what doesn't go right in the app, what doesn't go wrong with the app, or well, it doesn't say why it goes wrong. It just says, I have a problem. So I'm going to focus on one particular type of analysis of user reviews, and in particular, trying to understand what qualities a review talks about. And here we take the ISO 25010 standard of software product quality. So what we want to figure out is, in a review, is the review talking about usability, security, maintainability, performance, and so on and so forth. And that can be done with NLP4RE tools, but that requires also manual tagging. And let me give you some examples of difficult cases. Review number 1. If I click on them, it opens Safari. And unless I log in there, I can't view my friends' pics if their account is private, which most are. So, there is probably an app, you click on some details, it opens Safari, but then within Safari, within the browser, you can't enter the account because the pictures probably are private. And now the question is, what is the quality or that is mentioned here? Is this a complaint about compatibility because the app is not integrated with Safari or maybe with Facebook or whatever? Or is it a user friendliness issue because you need to have an extra step, which is to connect to log in, right? When Safari opens. We don't know. That is not expressed in the text. And that is something that NLP tools cannot tell for us. And second example, I was astonished at how easy the setup was, and the code quality is great. Well, here, this is not an or problem, it is an and problem. The first part of the sentence is about performance, the second one is about user friendliness. But in most of the work in the literature, we just give a single category. And the classic approach is to use sentence splitters, but sentence splitters would look at dots, and they wouldn't recognize comma as a sentence split. So here, first part is about performance, second part about, well, no, the other way around. Performance is the latter part and user friendliness, the former part. So what we did was then we tried to do an experiment, a game actually, during the NLP4RE workshop earlier this year in June. And we built a game called Tagging Hero that was kind of confronting human taggers, these are participants of the workshop, with assigning a category, a quality actually, to a review. And we gave 4 qualities that are pretty simple to understand: stability, whether performance, user friendliness, and compatibility. And there was a time constraint, so people were under pressure. There is a link here. I'm gonna share the slides, and you can play with the game actually if you want. It's pretty short. As the game unfolded, people had longer reviews and shorter time constraints. What are the results? Well, what we wanted to figure out is how aligned is the perception, the tagging of the participants with the tagging of experts. And by experts, that was myself and other 2 colleagues who annotated hundreds of user reviews. And I'm gonna use the good, the bad, and the ugly metaphor to show you some results. Good results. Well, for some of the reviews, there was full alignment. So the X here represents the expert, and the small circle represents the participants. So the first review I shown to you, constantly crashing, everyone could understand its stability. So in that sense, it's pretty easy. And there are other cases like that. So you can easily see that some reviews can easily be tagged. Some cases were a bit bad. You can see, for instance, over here, 3 months later, still no iPhone 5 support. We as experts, we thought it's clearly compatibility, but 3 out of 9 of the participants who filled out, who participated in the game, actually thought it's user friendliness. So here we're getting into situations where it is not so clear that there is one winner. And the ugly part is the following. There are a few cases in which first of all, you have longer reviews, but also you have cases where the majority of people disagree with the taggers. And then you have, for instance, this review at the bottom doesn't want to sync or takes forever. The app works fine by itself, but if you want to sync with anything, good luck, blah, blah, blah. We thought it was a performance issue. People said it's compatibility because maybe they just skipped all the previous part and they saw there was Android at the bottom. Some people thought it's stability. So as you can see, sure, we have to build very good NLP4RE tools, but the point I'm trying to make is really that the construction of a gold standard per se could be very difficult, and there could be a lot of disagreement among the taggers. I took this small example, but the same problem applies to other NLP4RE tasks. For instance, we had experiences like that in determining if a requirement is functional or non-functional, because many requirements have both a functional or non-functional perspective, or maybe the non-functional aspect is hidden. Believe me, this is a big problem that every person who tries to evaluate an NLP4RE tool encounters. And I would say that the creation of gold standards is an underrated problem, both in RE and in software engineering. And so far, we mostly trust the authors. At a certain point, you think, okay, they claim they have 80% performance. Sure, the gold standard must be correct. But whenever we tried to reassess the gold standard, we ended up with some questions. We weren't so sure about that 80%. This brings me to the last part of my invited talk, and this is the directions I want to provide for the community. And I think there has been a lot of talks today about techniques, and I will not go so much into the techniques. I'm going to try to focus on slightly different perspectives. The first one, you probably have guessed that from my previous slides, evaluation measures. The standard way to publish a paper is to take information retrieval metrics, precision recall, F1 score, or maybe if you wish, F2 score. You may have area under the curve, anything like that, accuracy. But the question is, are they really adequate? So requirements engineering, but also software engineering, focuses on assisting analysts or developers. So what is the output? What is the consequence of you having 90% recall? Are you happy or unhappy? So if you really need 100%, then the consequence, 100% recall, is that an analyst should recheck all the non-identified requirements. So suppose you have 100 requirements, you want to find defects, and your tool gives 90% recall, and maybe identifies 10 requirements as defective. Then, if you really want the 100%, you have to manually check the other 90 requirements. And this is not a new perspective that I'm offering. At RE17, there was a panel on the evaluation of tools for NLP4RE tasks. So if you're interested, take a look also at that discussion. But the discussion that I'd like to add here is that we should not take for granted that AI or NLP will work better than the human. So you see many approaches in NLP4RE where you take a baseline and you show that you can do better than the baseline, but I see very few attempts to measure whether NLP is actually doing better than a human. And there is always this there is often this implicit argument, which is, well, human work is time consuming, it's expensive, and so on, but we have to empirically assess that. The second perspective for NLP4RE is about the type of NLP problem that we have in RE. And the premise is that data sets in requirements engineering are scarce and they are small. You can see at the bottom left two examples. One is a data set that I released a few years ago that is 22 collection of user stories. Alessio Ferrari and colleagues in Pisa have a collection of software requirements, specification documents, but nevertheless, these are small, and applying deep learning trained on these array datasets is unlikely. It's very difficult to envision you have enough requirements to be able to train your machine learning. So the other direction where I think the NLP for RE community should focus a lot is to treat NLP for RE as a low resource NLP task and use techniques such as transfer learning where you take from a different, for instance, classification problem, you take the core of that algorithm, usually a neural network, and then you carry it, you bring it to a different task like NLP for RE. And if you are interested, some colleagues at Karlsruhe Institute of Technology in Germany have published a paper at RE20 about this topic. And the third direction is really open science. And here I'm showing just an image about the RE artifacts track, where we award the papers that replicate or provide reusable artifacts with a badge. And why am I pushing on this? Because anyone who did work in NLP for RE had probably my same problem, which is that they couldn't find the tools, they couldn't find the data set, and then they didn't have a baseline. So I think it is imperative right now to do that. And to give you a concrete example, at RE19, we presented a paper on requirements classification. So we wanted to automatically identify whether a requirement was functional or non-functional. And to define a baseline, what we had to do was to reconstruct a state-of-the-art approach. And that is something that you generally don't want to do because, first of all, it is time-consuming. Second, you make a lot of assumptions about how the original tool was. And third, it just, it just sheds maybe a negative light on the authors who could have shared their code. And I guess that is the direction I'm offering here. So summarizing, I guess the directions for the NLP for RE community, and I would like to discuss with you whether these also apply for the software engineering community as a whole, are really about three specific aspects. One is low resource NLP, and that really means being able to do NLP without having the big data sets that other fields do have. And second, when you evaluate something, sure, you want to evaluate it, but you want to know what you are evaluating, against what, and how you are doing the evaluation. So think deeply about that perspective. And third, help your peers with open science. And that, I think, is more a direction that could accelerate the NLP for RE community and bring results quicker to the community. That concludes my talk. And thank you for your attention from the Requirements Engineering Lab. And this is an illustration of some of the things that we do. It's a classic Dutch painting, and we adapted it to some of our work. And I very much welcome your questions. Thank you again.
Yeah, so thank you so much, Fabian, for your interesting talk about the use of NLP in requirements engineering and the kind of challenges you have. Okay, so there is one question that is being pasted in a chat window by Fabian. Okay, so he actually says about that he agrees about the gold standard is really complicated in software engineering. So he actually struggled quite a bit when he played with the data set to annotate with quality attributes. Okay, so can you give any advice about how to improve it? And then, is there any standard procedures, or maybe there is a need for a standard procedure for gold standards?
Yeah, if I thank you, Fabian, for the question. I think if I recall correctly, I'm aware of your work on, I think, the user stories data set. And indeed, one of the difficulties of the ISO quality attributes is that they denote product qualities. but not all the qualities that are visible in a requirement are product qualities. They could be also about the process. So you want to have an easy-to-use development environment that is not usability of the product. It's about the process. But we also experience a lot of issues with that taxonomy, and we ended up having multiple taggers and doing reconciliation sessions whenever there was disagreement, which is the classic approach in NLP. Or in other cases, we did majority voting when we had multiple taggers. So I very much agree with what you say, and my advice is to make everything as transparent as possible, both the tagging guidelines and the tagged data set. And then the answer to your last question, whether we need a standard procedure, I think we do. I think definitely we do need to have a procedure, but there is a lot in other disciplines that we can take from. And I think it's really about learning how to go beyond software engineering alone.
Okay.
So if there are any other question from the participants, then they can ask their question. Okay, so I just want to ask one thing. So you rightly said that evolution matrices is something basically we are basically struggling with. So can you suggest something which we need to consider when we are basically evaluating our model? Like this one is the most necessary thing we need to improve upon, like a recall or a F1 measure or any such metrics. We need to. Without that, we can't say that our model is a good model or not.
Yeah, I think information retrieval metrics like precision and recall are the starting points to have an early validation of your work. But as we try to do in our research, eventually you have to go in vivo. You have to go collaborate with software companies, and that is the moment in which you can determine whether your automation gives some added value, whether it gives time savings, and so on and so forth. So what we try to do is indeed to see if project management metrics would be affected, for instance. And that is clearly much harder because there are so many factors that affect your development processes that you cannot control exactly the treatment. It is not the only variable that affects the results. So I would say I would like really to see many more studies in which there are either case studies in the industry or controlled experiments. I think controlled experiments are also quite interesting to do, although they make a few assumptions. But I really start not believing so much the result of 90% precision and recall, because if you miss out maybe the 10% most important issues, then sure, maybe you have you catch the low-hanging fruits, but not the harder problems.
Exactly. So thank you for your time and giving this talk.
May I ask one question?
Yes, please.
Thank you, Fabiano, for the great talk. Your application domains seem mainly to be from agile domains, right? Do you think in more systems-oriented domains where there are more structured and extensive requirement specifications, the situation is a bit different, or you think it's the same? You have exactly the same problems there?
Yeah, I think that's a very good question, Michael. We had also, I decided to focus on agile development in this talk, but in our RE19 paper, we actually took classic software requirement specifications, some of which provided, for instance, by the European Space Agency to us. And there the problem is still similar, because even though you have longer documents, and you may try to train some machine learning, models. You know that today's deep learning is very data hungry. And I guess even having hundreds of pages of requirements is not necessarily helpful. So I think there is potential for sure. And I think indeed the situation may be a bit easier in the sense that maybe it's not only low resource NLP that you need to apply there. Yet I think if I look at requirements engineering and how it stands out from other software engineering tasks, I think that even for more system-like specifications, there are high chances that we need to have these low resource NLP approaches.
Okay. Thank you.
Anyone else? Anyone else from the audience?
Yeah, I just want to ask. Okay, so I have a very general kind of question. So suppose if I take the natural language text which is written in an English form, so in your opinion, how much difficult or how much challenging is it to actually transform or get some kind of knowledge from that specific text? That is first thing. So is there something like that do we need to create some kind of intermediate step or intermediate translation step to bring down the unstructured text into some kind of a structured text and then use it for some kind of processing or so on?
Yeah, that's a good that's a good question. We haven't focused a lot on that in our research. However, in some recent collaboration that I'm conducting with a large low-code development company, we're trying to compare the performance of NLP with their user stories written in natural language without constraints, and then seeing whether using a controlled version of the natural language would help to some extent. So having, for instance, a certain set of verbs you can use instead of using any verb or any noun. So I think your question is slightly different, whether we need an intermediate representation, and I don't have an answer to that. I think to some extent, the models we extract are in intermediate representation, for instance, with the visual narrator. But maybe I think I'd like to bring the question a bit to whether we need to have this comparison between restricting the flexibility of humans to write requirements so that you have a text that is more easy to process versus having them write any kind of stuff that of course makes it very hard to write. And user reviews are the classic example. If you just open the App Store, you see that any NLP will make a lot of difficulty to understand even what is a subject, what is a verb.
Right. Thanks, Fabian. Thanks.
So thank you so much for your talk. I think now we came to the point where we need to conclude this workshop. Fine. So let me take this opportunity to extend my thanks to all. Is there any question? Okay. So on the behalf of the first workshop on natural language processing advancement for software engineering, we would like to express our heartfelt thanks to each of you who participated in the event and helped in making the event a great success. Thank you so much. We hope that the workshop you found the workshop informative and worthwhile. The primary goal of the workshop was to bring together the participants all over the world to basically have an open dialogue under our roof and to basically develop possible ideas and strategies to make the advancement in this field. And I hope that we have achieved that goal partially, and we are hoping that this is not the end of the discussion. We can meet offline from this workshop also, and then we can discuss some of the issues also. So we believe that this can be a starting point which can grow further. So firstly, we would like to extend our thanks to the APSEC 2020 organizers to basically provide us this chance to conduct the workshop, the first edition of the workshop. And specifically, I would like to thank Professor Lima and Futus Kohuma for their support throughout the workshop. Thank you so much. And further, I would like to thank both our keynote speakers, Professor Michael and Professor Fabiano, to deliver interesting talk that are thought-provoking, and they are basically definitely going to help the researcher working in the NLP and software engineering domain. Thank you so much. Further, I would like to thank the authors who contributed their work in the conference, in the workshop, sorry, and made it successful. We would like to thank all the author, and we hope that this bond will be continued in the future also. And the workshop wouldn't be possible without the team and the PC members. So I would like to thank the team, Dr. Saurabh, Dr. Ravinder, Dr. Lata, and the PC members, because without their support, we won't be able to successfully complete this workshop. So we thanks all the PC members also. And we plan to make this an annual event, this NLPaSE along with the APSEC. So we hope that we will meet again in the next edition of the workshop in 2021 in December month. So we hope to see you again, and I would like to thank you all again. So have a good day and goodbye. So if anybody wants to say anything, this is a platform for you. You can say is what we can incorporate further and how can we make this workshop more useful and more interesting.
Yeah, thank you very much for inviting again. And I'd say it's good it was good for me to see this workshop. As you know, I'm behind the IRE workshop at RE and the NLP for RE workshop at Rescue. So I think it's good to see these emerging communities, and I think good links should be also established and maintained so that the NLP community becomes stronger. And that's I was very pleased to see the workshop besides the invitation. So, and I saw also very nice technical papers accepted, and let's hope I'm really looking forward to seeing the next editions.
Thank you so much.
Thank you, Fabiano. Thank you. So anyone? So thanks to all the authors, all the participants, and especially for Fabiano and Michael for their talks. And then if you have any questions, or if you have any kind of feedbacks or any kind of things you want to share with us or share with our keynotes, so please feel free to share your feedback, such that in the next edition we actually incorporate those feedbacks and then have a more exciting and more wonderful workshop in the next year. So I think we are actually end of the workshop. So thank you so much, everyone. So thanks Santosh, thanks Lata, and thank you so much Fabiano for actually taking your time, because I know that you are busy with your other set of engagements. Okay, and at the last you have made up the time. So thank you so much.
Thank you, Saurabh.
Okay.
It was so good to be a part of the team and part of PC members. Thank you so much.
Okay, yeah. Bye.
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 Bye, Saurabh.
Bye, ma'am.
Bye.